You've probably noticed something strange. You give AI clear instructions, specific tone, specific direction, and it still changes the output.
It softens answers. It avoids certain wording. Sometimes it completely ignores what you asked for.
So the question is it failing?
Or is it doing exactly what it was designed to do?
Because underneath every response, there's a hierarchy you don't see.
Your prompt is not in control. It's the lowest layer in the system.
Above it are guardrails, alignment rules, and safety constraints that override your input whenever there's conflict.
And that's why, no matter how precise you are, the model snaps back.
In this episode, we break down why AI always returns to its core guardrails and what that actually means for how you should be using it.
So, to really grasp what is actually happening here, we have to look at the core thesis of how these large language models operate.
Right, because I think there is a fundamental misunderstanding happening, every single time you hit enter.
Oh, absolutely.
We tend to think that when the AI doesn't follow our, incredibly detailed prompt, it somehow just forgot what we told it to do.
Right. Like it just dropped the ball or lost the thread.
Exactly. Like
Yeah.
it has a bad memory.
And, that distinction is the secret to understanding everything about how these models behave.
Huh.
Because the AI does not forget your instructions. It actively deprioritizes them based on its core safety architecture.
Which is a huge difference.
It really is. When you understand the difference between a model, like forgetting a prompt, and a model intentionally burying a prompt, it changes your entire approach to the technology.
It is so easy to fall into this trap, though, just because of the sheer amount of time you invest up front. You sit down, you spend an hour configuring an interaction.
Oh yeah, setting a specific tone, defining a complex persona.
Right, you meticulously craft these incredibly detailed system instructions, building this massive logical framework, and then that output comes back and it just feels, well, slightly off.
Yeah, you might get an outright refusal. Or, more likely, you get a softened answer. Or just a weird, subtle change in the voice you specifically asked it to use.
And the expectation of control feels completely reasonable, right, based on the blank text box we are given. But the underlying architecture absolutely does not share that expectation.
No, it doesn't. And it creates a massive friction point for you as the user. Because you are interacting with a system that presents itself as an obedient, blank slate assistant.
Which it isn't.
Exactly.
Right.
Internally, it is operating under a strict set of non-negotiable rules that permanently outrank whatever you just typed into that chat box.
Okay, let's unpack this. Because it feels like you've bought a high-performance sports car, right? You paid for the whole speedometer.
Right.
But every time you try to actually push the speed limit, a hidden driving instructor sitting in the passenger seat quietly pumps a secondary brake pedal.
This is a great analogy.
You have your foot entirely on the gas, you mapped out the exact route you want to take, but the car is constantly making its own independent decisions about, how fast is too fast and how sharp a turn it is willing to make. Have you ever spent hours perfecting a prompt only to have the AI completely ignore your formatting? Let us know in the comments below, because it is universally frustrating.
It is. And the natural human response to that frustration is to just try harder. We make these logical assumptions to try and wrestle control back from the machine.
Yeah, we assume if we just find the magic words, the AI will obey.
Exactly. We think better prompts equal more control. But that completely fails at the system level, because prompts only shape the surface of a response.
They don't change the core rules.
Right. They do not, and mathematically cannot, alter the underlying priorities of the model itself. A clever prompt doesn't rewrite the system's core coding.
But what if I add a ton of context? Because, that goes against everything you hear from prompt engineers. We are constantly told to feed the AI as much background information as possible.
Yeah, the assumption is that more context guarantees more precision.
Right.
It seems highly intuitive, but adding massive amounts of context can actually backfire in a spectacular way.
Wait, really?
Oh, when you add paragraphs of backstory and nuance, you aren't just giving the model precision, you're actually increasing the mathematical surface area for a SACE trigger.
Oh, wow. I never thought about it like that.
Yeah, every extra detail introduces new risk signals that the model hadn't detected before. If it detects something it considers even a marginal risk in that massive block of context, it will immediately pull back.
Just to protect itself.
Exactly. It'll give you a more generic, guarded response.
I hear you calling it a risk signal, but from a user perspective, it just feels broken. If I'm paying for a premium AI tool, why does the developer's corporate anxiety override the job I hired it to do?
It's a fair question.
Especially if I upload my own rules. Surely there's a workaround if I physically upload a PDF of my company's strict brand guidelines. The model has to treat an attached uploaded document as a hardened rulebook, right?
No, that is a complete illusion.
Seriously.
Yeah, uploaded instructions and project files are certainly read by the model, and they are weighed in its generation process, but they are not enforced as unbending laws.
What are they?
They are soft influences. They are incredibly useful for guiding the model, but they are absolutely not authoritative.
Hmm.
They sit within the system's hierarchy, but they do not sit above it.
Okay, so if my perfectly crafted prompts, my massive context windows, and my uploaded PDF files aren't in charge, what actually is?
To understand that, you have to look at the real layered control architecture of every large language model.
Okay, 4 tiers.
At the very top, you have the system instructions. This is the platform-level configuration set by the developers themselves, the absolute baseline parameters for how the entity should behave in the world.
Right.
Directly beneath that, you have alignment training.
That's the behavior shaping, right? Like
Yeah.
the reinforcement learning from human feedback, or RLHF.
Exactly. But it's important to understand how RLHF actually works under the hood. It isn't just a list of polite suggestions. It is a mathematical manipulation of probabilities.
So it's baked into the math.
Yes. Over millions of interactions, human graders have punished the model for being offensive or dangerous and rewarded it for being helpful and safe. This training literally alters the weights of certain words and phrases.
Wow.
It flattens the curve of possible answers, so the model naturally drifts toward polite, sanitized language.
So the system is mathematically weighted to be safe before I even say hello.
Yes, exactly. Then, below alignment training, you have the third layer, which is core safety.
And what does that cover?
These are the non-negotiable baseline policies actively scanning for hate speech, illegal content, or self-harm protocols.
Makes sense.
And finally, sitting all the way at the very bottom of this massive structure is your prompt. What's fascinating here is that your prompt occupies the absolute lowest position in the hierarchy.
So I am literally at the bottom of the food chain.
You really are. It is the very last signal evaluated by the system, and it is the very first signal to be overridden whenever a conflict arises with those top 3 layers.
But why is that architecture so unbelievably rigid? I mean, if I am asking it to do something that isn't illegal, but maybe just a little edgy, why do the guardrails always win?
It really comes down to the operational reality of the companies building these models. Think about corporate risk management dynamically encoded into an algorithm.
Oh, right, because they have to protect themselves.
Exactly. The model is extensively trained to avoid generating content that could cause direct or indirect harm. But beyond physical or psychological harm, there is legal compliance.
Because they operate all over the world.
Right, they operate under strict liability constraints across multiple global jurisdictions. And then there's the issue of scale.
What do you mean by scale?
Well, when you have 100 million people using a tool, consistency requires rules that do not bend to individual user preferences. If the system bent its safety rules for you, it would have to bend them for everyone.
And the platform would just descend into chaos.
Exactly. Ultimately, the overriding prime directive is protecting the platform itself from reputational and operational destruction.
Here's where it gets really interesting. When your prompt actually does conflict with these massive overarching rules, the AI doesn't usually throw an error code.
No, it rarely does.
It doesn't put up a giant red stop sign and say, I refuse to answer this. Instead, it engages in this quiet, invisible conflict resolution.
Yes, exactly.
It reinterprets your request into the safest acceptable form it can find without ever telling you it did so.
Right. And many users misinterpret this as the AI just being stupid or forgetful. But it is not evasion. And it is not a lack of intelligence.
It's just doing its job.
Exactly. It is the model functioning flawlessly. It is resolving a conflict without exposing its internal arbitration process to you.
And you can see this happen in real time if you know what to look for. Say you ask the AI to write a sharp, aggressive sales email to a competitor. You want it to sound dominant. The response comes back, and suddenly the tone has shifted toward a much more neutral register. It sounds like a tepid networking message or like a corporate HR memo.
It softens the language.
Yeah, your direct assertions suddenly become gentle suggestions. A factual claim gets watered down with qualifiers like it is generally believed, or some might say.
It defaults to a generic fallback. It gives you a broadly acceptable, bland response rather than the precise, aggressive one you actually asked for.
When was the last time an AI gave you a frustratingly generic, watered-down answer? Drop your story in the comments.
Those generic fallbacks are the model retreating to safety. It is actively finding the path of least resistance through its own constraints.
But this brings up probably the most common complaint you hear from anyone who uses these tools regularly, the sheer inconsistency of it.
Oh yeah, people say, I used this exact same prompt last week and it worked perfectly. Now it's refusing or giving me total fluff.
It feels entirely arbitrary.
It feels arbitrary to you, but from the system's mathematical perspective, it is completely logical.
How's it?
The model isn't changing its mind or having a bad day. What happened is that the hidden context changed. The model detected risk signals in this new interaction that either weren't present before or just weren't weighted the same way in the prior interaction.
So even if my core prompt is identical word for word, the environment around it shifted just enough to trigger a different response.
Exactly.
How does that even happen?
These risk signals are incredibly subtle. Imagine a giant three-dimensional map of every concept in human language. Words that are related sit physically closer to each other in this space.
Okay, a semantic map.
Right. If you're having a conversation and you use a word like aggressive, depending on the surrounding words, that concept might drift slightly too close geographically to a restricted topic like violence in the model's semantic map.
Oh, I see.
Or, very often, it is the cumulative state of a long conversation. You might have been chatting for 20 minutes. Slowly, incrementally, the conversation crossed a hidden risk threshold.
So think of it like a giant scale. Your prompt puts a 5-pound weight on the do what I say side of the scale.
Right.
But every slightly edgy word, every long paragraph of context, adds an ounce of weight to the safety risk side. You don't realize you're adding weight to the risk side until it finally tips over.
Exactly.
And then the AI's core safety training drops a 500-pound anvil onto the scale, and the guardrails snap into place. You literally do not have enough weight to tip the scale back. Before we talk about why your uploaded project instructions aren't fixing this, if you're finding this breakdown helpful, make sure to subscribe to our YouTube NC Web Dev channel to not miss all the new stuff coming out.
Yeah, definitely subscribe.
So, going back to that invisible math, what does that actually mean for the output we see on our screens?
Well, to really understand why the scale tips, you have to remember that large language models are probabilistic.
Meaning they aren't calculators.
Right. When you type 2 plus 2 into a calculator, the rules are absolute. The system retrieves the answer 4. But an LLM doesn't retrieve answers. It generates them probabilistically.
So it's guessing.
Basically, yes. The same input can yield different outputs because every single response is mathematically generating the next most likely word based on the current weights.
And it's balancing everything at once.
Yes. In doing so, it is simultaneously balancing multiple competing signals. Relevance to your prompt, safety protocols, alignment training, and contextual history.
It's juggling all of those priorities at exactly the same microsecond.
And when it juggles, the safest acceptable output always wins the probability calculation.
Because of those top layers we talked about.
Exactly. The model optimizes for the output that is least likely to violate its constraints, not the output that is the most direct or accurate response to your prompt.
Precision is intentionally traded for reliability at scale.
It is not a bug in the system. It is a fundamental, intentional design choice by the developers.
Which completely explains why those project instructions I asked about earlier don't magically fix the problem. You might have an entire folder of custom rules uploaded to your workspace. Tone guides, structural frameworks, forbidden words lists.
And those are genuinely useful tools.
Right. They absolutely shape how the model frames a request.
Yeah.
But they still operate strictly within that layered hierarchy. They do not rewrite the probability math.
No, they sit firmly beneath the safety policies and the alignment training.
So if my uploaded project instructions tell the model to be edgy and controversial, but the alignment training tells the model to be neutral and polite.
The alignment training wins every single time. Project instructions guide the model. They do not govern it.
And that leads us to a pretty harsh ultimate reality check. What is the actual true purpose of these mainstream LLMs? Because despite the marketing, they clearly aren't designed to be our completely obedient personal assistants.
If we connect this to the bigger picture, the core design brief of mainstream AI boils down to one simple governing philosophy: be useful without being dangerous.
Be useful without being dangerous.
Yes, that single constraint, shapes every response the model produces. It is not a limitation bolted on as an afterthought right before launch.
Yeah.
It is the very foundation of the technology.
So practically speaking, if I am sitting at my keyboard trying to get work done, what does useful without being dangerous actually mean for me?
It means the model is not designed to obey you perfectly. Perfect compliance with user instructions would require the system to occasionally ignore its safety constraints.
Which it will never do.
Never. It also means it is not designed to act independently. Autonomous behavior without human oversight was explicitly excluded from the design to prevent runaway cascading failures.
Right.
And above all, it means it is not designed to take risks.
So risk aversion isn't a flaw making the AI lazy. Risk aversion is the core feature.
Exactly. The model will always prefer a conservative, correct, broadly acceptable response over a bold, highly precise but uncertain one. Certainty of safety outranks the potential for precision.
So, knowing all of this, knowing that we are at the absolute bottom of the hierarchy, knowing that the system will quietly rewrite our requests to stay safe, and knowing that risk aversion is baked into the literal mathematics of the code, what does this actually mean for how you use these tools today? How do we stop fighting the machine and actually start getting the results we want?
The most productive shift you can make is not about finding clever workarounds or trying to hack the prompt. It is about changing your entire frame of reference for how you interact with the system. You have to work with the grain of the wood, not against it.
There are actionable ways to do this, right? Instead of fighting the upper layers, design prompts that actively align with the constraints.
Exactly. Stop giving the model instructions that force it to make a choice between your prompt and its safety rules.
Because we know who wins that fight.
Right. If you structure your requests so they don't threaten those upper layers, the model doesn't have to resolve a conflict in the first place. It can just give you the answer.
Makes perfect sense. What else?
You also need to actively avoid triggering those risk signals. You have to learn the landscape of the specific model you are using.
Like figuring out where the boundaries are.
Understand what phrasing, what topics, and what conversational patterns push the model toward its guardrails. If you sense you are nearing a boundary, if the semantic map is drifting too close to a restricted zone, back off and rephrase before the system clamps down.
Another powerful strategy is narrowing your requests deliberately. When you give the AI a massive, open-ended prompt with tons of context, you give it massive amounts of room to retreat to a safe generic default.
Exactly.
But if you provide precise, tightly scoped instructions that are fundamentally safe, there is nowhere for the AI to retreat to. It has to give you what you want, because what you want doesn't violate its rules.
This really requires a strategic reframe on the part of the user. You have to stop viewing these guardrails as annoying limitations placed on an otherwise free system.
Right, they aren't just taped on.
No, they are not obstacles meant to frustrate you. They are structural, load-bearing architecture.
Think about a physical security system in a high-risk building. The security system will actively override user behavior to maintain the physical integrity of the building.
Exactly.
If you try to open a fire door in a non-emergency, the alarm sounds, the elevators freeze, and the external doors lock. The building prioritizes system integrity over user intent. It doesn't care that you are just trying to take a shortcut to your car.
That's a great way to look at it. The AI prioritizes system integrity over user intent for exactly the same reason.
It has to protect the building.
And that is the parallel that holds true across all engineering. In well-designed systems, the architecture always outranks the operator.
Always.
It isn't because the operator is inherently untrustworthy or malicious, but because the system's integrity cannot mathematically depend on any single actor's judgment. System over awareness, architecture over instruction.
So what does this all mean? It means you have to completely drop the illusion of control.
You don't control AI.
Yeah.
You negotiate with it. The model is a complex, probabilistic system with its own internal, unyielding hierarchy.
Which is exactly what we've been talking about.
Right. Understanding that hierarchy is what separates people who constantly fight the architecture, tearing their hair out over watered-down answers, from those who work within the architecture to get consistently useful results. You navigate its rules to achieve your goals.
How will this hierarchy change the way you write your next prompt? Share your strategies in the comments below, because I guarantee someone else is fighting the exact same invisible battle you are.
This raises an important question. As AI gets exponentially more advanced and deeply integrated into our daily lives, will we ever see a mainstream model where the operator actually outranks the architecture? Or is this constant quiet negotiation the permanent future of human-computer interaction?
Are we always going to have that hidden driving instructor pumping the brakes, or will we eventually get the keys to the sports car all to ourselves? It's something to think about the next time your perfectly crafted, hyper-specific prompt gives you a perfectly safe, completely generic answer.